The more humanity studies worlds beyond its own small solar neighborhood, the more unsettling the universe becomes. What once felt orderly, stars with planets neatly circling them, systems resembling our own, has collapsed into something far stranger, far more chaotic, and deeply unsettling. The universe does not merely host wonders. It harbors cosmic nightmares, worlds that should not exist, environments that mock the rules we believed governed reality, and planetary systems that feel less like natural outcomes and more like accidents frozen in time. For most of human history, the idea of planets beyond our solar system existed only as speculation. Philosophers wondered, writers imagined, scientists suspected. Yet, until the final decade of the 20th century, there was no proof, only belief. Humanity stared into the night sky, assuming that stars like the sun must host their own families of planets, but the cosmos offered no confirmation. Space remained silent. Then, almost suddenly, the silence broke. In the early 1990s, the first confirmed exoplanets were detected, distant worlds orbiting alien stars. The discovery was not triumphant in the way many expected. It was unsettling. These planets did not resemble Earth. They did not resemble anything familiar. Some moved too fast, others burned too hot. Many seemed locked in gravitational prisons that would tear apart any world shaped like our own. With each discovery, confidence gave way to unease. As telescopes improved and detection methods sharpened, the count of known exoplanets exploded, from dozens to hundreds to thousands. Today, researchers have identified more than 5,000 confirmed exoplanets, with countless more waiting in the data, unseen but undeniable. And the emerging pattern is clear. Our solar system is not the norm. It is an exception. Most stars do not host calm, evenly spaced planets. They host chaos. Across an estimated hundreds of billions of galaxies, each containing hundreds of billions of stars, the universe may hold trillions upon trillions of planets. Some orbit gently. Many do not. Some form peacefully. Others survive violent births and catastrophic reshuffling. Each discovery forces scientists to revise their models, rewrite assumptions, and accept an uncomfortable truth. The universe is not designed for comfort or familiarity. It is designed for extremes. At first, planetary science relied on only 8 planets, our own, to explain how worlds form and evolve. That narrow sample painted a picture of balance: rocky planets close to the star, gas giants far away, stable orbits, predictable cycles. But exoplanet research shattered that illusion. Worlds were found hugging their stars so tightly that a year lasted less than 2 Earth days. Others followed elongated, violent orbits that flung them from near-freezing darkness to blazing proximity in a single cycle. Some planets appear swollen, bloated by relentless stellar heat. Others are stripped of atmosphere entirely, exposed cores screaming silently into the void. A few exist in places where planets should never have formed at all, too far from their stars, too massive, too old, or born in environments thought hostile to planetary creation. And then there are the truly horrifying ones, worlds where the surface is never solid, where the sky rains metal, where temperatures vaporize stone, where winds move faster than sound itself, flaying anything unfortunate enough to exist within them. These are not just strange planets. They are warnings, reminders that the universe is indifferent to life and hostile to familiarity. As astronomers peer deeper into space, they are also looking backward in time. Light from distant planets travels for hundreds, thousands, even billions of years before reaching Earth. Each detection is a glimpse into a different era of cosmic history. Some planets are ancient beyond comprehension, formed when the universe itself was young, before many of the elements essential to life even existed. Others are caught mid-destruction, spiraling toward their stars, their atmospheres boiling away molecule by molecule. The universe does not preserve, it consumes. What unsettles scientists most is not the existence of bizarre planets, but their frequency. The cosmos does not produce a few anomalies scattered among orderly systems. It produces anomalies as the rule. Worlds like Earth may be rare. Stability may be rare. Calm may be rare. And loneliness, perhaps, is not. Modern telescopes now allow astronomers to do something once unthinkable: analyze the atmospheres of planets hundreds of light years away. By studying how starlight filters through alien skies, scientists can identify metals, gases, and compounds swirling in environments no human will ever visit. This is not exploration by foot or machine. It is remote sensing of alien air, a kind of cosmic surveillance that reveals conditions both fascinating and deeply disturbing. The universe is revealing itself not as a place of gentle variation, but as a vast laboratory of extremes, a place where physics pushes itself to its limits, where planets are stretched, scorched, frozen, torn apart, and reshaped over unimaginable spans of time. And as humanity catalogs these worlds, one realization grows heavier with every discovery. The universe does not care what we expect. It only reveals what exists, and what exists is stranger, darker, and far more unsettling than we ever imagined. As the catalog of alien worlds expanded, astronomers began to realize that naming them planets was almost misleading. Many of these objects shared little more than gravity with the familiar worlds of our solar system. They were not merely different, they were hostile expressions of cosmic physics shaped by forces so extreme that they challenged the limits of imagination. Among the earliest shocks were the so-called hot giants, enormous gas worlds orbiting so close to their stars that their atmospheres were permanently ablaze. These planets did not form where they now reside. All evidence suggests they were born far away in colder regions before being dragged inward by violent gravitational interactions. Their final positions placed them so near their stars that tidal forces stretch them, warp them, and slowly tear them apart. On these worlds, a year may last less than a single Earth day. One side of the planet faces the star forever, locked in an eternal noon. The other side never sees light, frozen in endless night. Temperatures on the day side soar high enough to vaporize iron, while the night side collapses into crushing cold. Winds roar between hemispheres at thousands of kilometers per hour, carrying clouds of molten metal through skies that glow faintly from heat alone. There is no surface, no land, no refuge, only pressure, heat, and motion without rest. Then came the discovery of lava worlds, rocky planets orbiting so close to their stars that their crusts cannot solidify. Entire hemispheres are oceans of magma, glowing red beneath thin, poisonous atmospheres. Continents do not exist, mountains melt. Any structure formed by geology is erased almost as soon as it appears. These planets are caught in a permanent state of destruction, neither fully solid nor fully fluid, suspended between formation and annihilation. On some of these worlds, astronomers detected clouds of vaporized stone drifting through the upper atmosphere. The very ground is airborne. Equally unsettling are the ice giants, adrift in darkness, planets that wander far from their stars or were never bound to one at all. These rogue worlds drift alone through interstellar space, untethered, unseen, carrying frozen oceans beneath kilometers of ice. Without starlight, their surfaces are locked in eternal night. Yet deep beneath the ice, gravitational compression and radioactive decay may generate warmth, sustaining hidden oceans in complete isolation. If life were to exist there, it would never know a sky, never know a sunrise, never know a star. The universe, it seems, has no requirement for light. Some planets defy expectations in even more disturbing ways. Astronomers have found worlds with impossibly dense cores, remnants of planets that once possessed thick atmospheres and outer layers, only to have them stripped away by relentless stellar radiation. What remains is a naked planetary heart, a massive metallic core exposed directly to space. These worlds orbit their stars like scars, evidence of prolonged cosmic violence. Other planets orbit not one star, but two, or sometimes three. In these systems, suns rise and fall in unpredictable patterns. Shadows behave strangely. Seasons collapse into chaos. The sky is never stable, and gravity is never constant. Planets in these systems endure constant orbital stress, their paths wobbling under competing gravitational pulls. Some are flung into space, others spiral inward to fiery deaths. Stability, again, is rare. But perhaps the most disturbing class of worlds are those that exist on the edge of tidal destruction. These planets orbit so close to massive stars or dense stellar remnants that gravity stretches them into elongated shapes. Their interiors churn violently. Volcanism never stops. Quakes ripple endlessly through their crusts. The planet itself screams silently as it is slowly pulled apart, grain by grain, into the gravity well of its parent star. Astronomers do not merely observe these worlds, they watch them die. What emerges from all these discoveries is a universe dominated by instability. Planetary systems are not quiet, settled arrangements. They are battlegrounds shaped by collisions, migrations, and catastrophic interactions. Worlds are born, displaced, shattered, and erased with little ceremony. And yet, amid this chaos, scientists continue searching for something fragile: balance. They search for planets not too close, not too far, worlds with atmospheres thick enough to protect but thin enough to allow light, surfaces that are solid, oceans that are stable, climates that persist long enough for complexity to emerge. These rare conditions define what researchers call habitable zones, but even that term is deceptive. Habitability is not guaranteed by distance alone. It requires a delicate chain of circumstances, any one of which can collapse without warning. The deeper humanity looks into space, the more unsettling the implication becomes. Earth-like worlds may be cosmic anomalies, not outcomes. This realization does not diminish Earth's importance, it amplifies it. Our planet is not a default, it is a survivor. A world that endured bombardment, chaos, stellar evolution, and gravitational upheaval, yet remained intact long enough for life to take hold. And as telescopes continue scanning the dark, revealing worlds of fire, ice, and endless night, a quiet question begins to form, not spoken, aloud, but impossible to ignore. If the universe produces so many worlds that cannot support life, what does that say about the ones that do? As discoveries mounted and catalogs grew heavier with data, a new and deeply unsettling pattern emerged, one that could not be plotted on charts or reduced to equations. It was not about temperature, distance, or mass. It was about absence. For all the worlds revealed, burning, frozen, shattered, or drifting, there was something profoundly missing. The universe was loud with activity, yet silent of voices. Advanced instruments began to search not just for planets, but for signatures, chemical imbalances, repeating signals, structured emissions, anything that could not be explained by natural processes alone. Astronomers examined atmospheric compositions for traces of instability that might suggest industrial activity. They listened for narrow band signals that could indicate artificial origin. They searched for megastructures, vast constructs that could dim stars in unnatural ways. And again, they found nothing. This silence was not comforting. It was disturbing. Statistically, the universe should be overflowing with life, with trillions of planets and countless stars older than the sun by billions of years. Intelligent civilizations should not be rare. Some should be ancient beyond comprehension. Some should have reshaped their star systems. Some should have left scars visible across interstellar distances. But space remained quiet. This contradiction between overwhelming probability and absolute silence became known as the Great Absence. It forced scientists to confront possibilities far darker than simple loneliness. Perhaps life is not rare, but fragile. Perhaps intelligence does not endure. Or perhaps the universe itself enforces limits, filters that erase civilizations before they can leave lasting marks. As telescopes probed deeper, they found worlds that once may have been alive. Planets with atmospheric remnants suggesting long-lost oceans. chemical traces hinting at biological processes that had ceased billions of years ago. These were not thriving ecosystems. They were fossils, planetary graveyards frozen in time. Some worlds appeared to have undergone catastrophic atmospheric loss in a geological instant, stripped bare by stellar flares or runaway greenhouse effects. Others showed evidence of global freezing events so severe that recovery would be impossible. Entire biospheres may have vanished without warning, erased by cosmic circumstances beyond control. Life, it seemed, was not just rare, it was vulnerable. This realization led researchers to question not just planetary conditions, but time itself. Civilizations may rise and fall quickly on cosmic scales. Even a society lasting 1,000,000 years, an eternity by human standards, would vanish like a spark against the universe's age. If civilizations rarely overlap in time, they may never encounter one another at all. The universe may be full of ghosts. More disturbing still was the possibility that intelligence carries an inherent instability. The same curiosity that drives civilizations to explore may also lead them toward destruction. Energy consumption grows. Technology accelerates. Environmental balance fractures. On cosmic timescales, unchecked progress could become a self-eliminating force. Some scientists propose that the universe is not silent because life is absent, but because survival requires quiet. Perhaps advanced civilizations learn to hide, suppress emissions, and avoid detection. Perhaps the universe is not empty, but cautious. Or perhaps something else listens. As observational power increased, attention turned toward anomalies, regions of space where expected patterns failed, stars with unexplained dimming, galaxies with irregular energy distributions, signals that appeared once, never repeating, never explaining themselves. These were not clear messages. They were glitches in expectation, subtle enough to dismiss, yet persistent enough to unsettle. One recurring mystery involved fast, intense bursts of energy originating from distant galaxies, brief flashes lasting milliseconds, releasing more power than stars emit in days. Their origins were unclear. Natural explanations existed, but none were complete. Each burst raised the same uncomfortable question: what kind of process produces so much energy so precisely? The universe, once thought passive, began to feel observant. The deeper humanity searched, the more the cosmos revealed itself as a place shaped by destruction, erasure, and silence. Stars exploded, planets burned, civilizations, if they ever arose, left little behind. Space was not welcoming, it was selective. And slowly a new idea took root, one that transformed curiosity into dread. What if the universe is not empty because life fails, but because something ensures it does? The question could not be tested. It could not be measured, yet it lingered in every unanswered signal, every dead world, every quiet star. The universe no longer felt like a place waiting to be explored. It felt like a place that had already been explored and emptied. And somewhere in the vast distance between galaxies, in the endless dark where light thins and time stretches, the silence remained unbroken. Not peaceful, but watchful. As humanity struggled to understand the silence, attention shifted from what could be seen to what could not. If the universe appeared empty on the surface, perhaps its true structure lay hidden beneath perception, woven into forces that shaped everything while revealing almost nothing. This was the realm of the unseen, the invisible architecture holding galaxies together and guiding the fate of worlds. At the heart of this realization was a disturbing truth. Most of the universe is invisible. Stars, planets, nebulae, everything that glows or reflects light, accounts for only a small fraction of reality. The rest is dominated by something that does not shine, does not speak, and does not reveal itself directly. Yet without it, nothing would exist as it does. This hidden framework is what scientists call dark matter. Its presence was first inferred not through sight, but through motion. Galaxies rotated too fast. Stars at their edges moved as if bound by gravity far stronger than visible matter could produce. Without an unseen mass holding them together, galaxies should have torn themselves apart long ago. But they did not. They endured, bound by something unseen, something massive, something everywhere. Dark matter does not interact with light. It passes through ordinary matter as though it were not there. Entire planets could drift through clouds of it without consequence. And yet, on the grandest scales, it dominates structure itself. Galaxies form along vast filaments of dark matter, creating a cosmic web stretching across the universe. Immense strands linking clusters of galaxies like beads suspended on invisible threads. This web is ancient, older than stars, older than planets. It formed when the universe was still young, guiding matter into shape before light itself had fully emerged. In a very real sense, dark matter built the universe before the universe was visible. But dark matter was only the beginning. As researchers mapped cosmic expansion with increasing precision, they uncovered something even more unsettling. The universe was not merely expanding, it was accelerating. Galaxies were not drifting apart at steady rates. They were being pushed away faster and faster, as if space itself were swelling with growing urgency. The force behind this acceleration became known as dark energy. Unlike dark matter, which binds, dark energy repels. It stretches space, it weakens gravity across vast distances, and it appears to grow stronger as the universe ages. The more space expands, the more dark energy dominates, driving further expansion in a feedback loop that cannot easily be stopped. Dark energy does not act like any force humanity understands. It has no source that can be isolated, no mechanism that can be controlled. It does not push objects through space. It expands space itself, carrying galaxies along like debris on a rising tide. Together, dark matter and dark energy form a terrifying symmetry. One builds structure, the other erases it. Between them, visible matter is little more than residue. As billions of years pass, this invisible architecture dictates the universe's fate. Galaxies drift farther apart, clusters become isolated islands, light from distant stars stretches, reddens, and eventually fades beyond detection. Entire regions of the cosmos slip permanently beyond reach, their information lost forever. In the far future, observers in distant galaxies, if any exist, will see only their local stars. The wider universe will vanish from view, not because it no longer exists, but because expansion has rendered it inaccessible. Knowledge itself will collapse inward. The universe is not ending in fire or collapse, it is fading into isolation. And within this accelerating emptiness, something even more unsettling emerges. Time itself begins to lose meaning. Processes slow, interactions become rare, energy gradients flatten, complexity becomes harder to sustain. The universe trends not toward destruction, but toward stillness. This is not a dramatic end. It is a quiet one. Stars burn out. Black holes evaporate over unimaginable spans of time. Matter decays. Eventually, even atomic structure may dissolve. What remains is a universe stretched thin, cold, dark, and nearly uniform, an echo of its former complexity. And yet, within this bleak projection, one final mystery remains unresolved. If dark energy dominates everything, why did it wait? For billions of years, expansion was slow. Gravity had time to build galaxies, stars, planets, and life. Only later did dark energy rise to dominance. This delay allowed structure to emerge before ensuring its eventual erasure. The timing is precise, almost unnervingly so. Had dark energy been stronger earlier, galaxies would never have formed. Had it been weaker, collapse might have followed instead. The universe exists in a narrow window between formation and dissolution, balanced on a cosmic edge that appears finely tuned. Whether this tuning is coincidence, inevitability, or something else entirely remains unknown. But as humanity peers deeper into the invisible forces shaping reality, one conclusion becomes impossible to ignore. The universe is not merely vast, it is governed, not by intention, not by design as we understand it, but by rules so deep, so ancient, and so indifferent that life itself feels like a brief disturbance in an otherwise relentless process. A moment of awareness inside an architecture that does not notice it exists. By the time humanity began to grasp the full scope of the universe's invisible architecture, a deeper realization set in, one that no equation could soften and no discovery could reverse. The universe was not simply expanding. It was moving toward an outcome that had been encoded into its structure since the very first moment of existence. The cosmos was never neutral. It was never stable, and it was never meant to last. From the instant space and time ignited into being, the universe carried within it the conditions of its own dissolution. Dark matter assembled the scaffolding. Dark energy waited patiently. Stars ignited, burned, and died. Galaxies formed intricate spirals and clusters only to be slowly pulled apart by expansion so subtle it took billions of years to notice. The universe did not rush toward its end. It drifted. As epochs passed, the sky itself began to change. Galaxies that once crowded the night sky receded beyond visibility. Their light stretched into wavelengths, too long to detect, redshifted into darkness. One by one, the universe erased its own history, not through destruction, but through distance. Civilizations, if any endured long enough, would eventually look outward and see almost nothing. No cosmic background, no distant galaxies, only their local stars, isolated in a vast black ocean. To them, the universe would appear small, empty, and deceptively simple, its true scale lost to expansion. Knowledge itself had an expiration date. Long before the last stars died, the universe would become unknowable. The evidence of its origin, the afterglow of creation, the faint whispers of early structure would fade beyond reach. The universe would still exist, but its story would be unreadable. This was not chaos. This was order taken to its extreme. As trillions of years passed, star formation slowed, gas clouds thinned, galaxies exhausted their fuel. Red dwarfs, small, dim stars, became the final sources of light, burning slowly for unimaginable spans of time. Around them, planets cooled, froze, and fell silent. Any life that survived would do so under fading suns, adapting to scarcity, darkness, and isolation. Eventually, even these stars would die. What followed was an era almost impossible to imagine, a universe populated not by stars but by remnants, white dwarfs cooling into black dwarfs, neutron stars drifting silently, black holes dominating mass, swallowing stray matter with slow, indifferent precision. Time stretched. Processes that once took seconds now took eons. Motion itself slowed as energy gradients flattened. The universe did not explode or collapse. It settled toward equilibrium, toward sameness, toward stillness. Then came the age of black holes. They lingered long after all else had faded, immense and patient, curving space around them like scars in reality. But even they were not eternal. Over timescales so vast that numbers lost meaning, black holes began to evaporate, leaking energy into the void through subtle quantum effects. One by one, they vanished, leaving behind nothing but diluted radiation. And when the last black hole disappeared, the universe crossed a threshold. No stars, no planets, no structures, no observers, only particles drifting in near-perfect uniformity across an ever-expanding void. This was heat death, not an event but a condition, a universe where no work could be done, no complexity sustained, no change meaningfully occurred. Time still existed, but nothing marked its passage. Cause and effect blurred into irrelevance. The universe became quiet in a way deeper than silence. Yet even here, at what seemed like the absolute end, uncertainty remained. Some theories suggested that this was not the final chapter, but a pause. That quantum fluctuations, rare and subtle, might eventually spark new beginnings. Tiny disturbances in empty space could, given enough time, inflate into new universes, new regions of space-time detached from the old, carrying different laws, different constants, different possibilities? If so, then the universe did not truly die. It shed itself. In this view, creation and destruction are not opposites, but phases. Universes bloom, expand, fade, and give way to others, each unaware of what came before. No memory passes between them. No signal survives the transition. Each universe is alone, complete, and temporary. And humanity, brief, fragile, conscious, exists only within one thin slice of that endless process. This understanding reshapes everything. The universe is not built for life. Life is something that happens within it, briefly, improbably, and without guarantee of continuation. Awareness flickers into existence, contemplates the cosmos, and vanishes, leaving no trace that it ever occurred. Yet, in that fleeting moment, the universe becomes aware of itself. Stars do not question their fate, galaxies do not fear isolation. But for a short span of cosmic time, matter arranged itself into minds capable of wonder, dread, and understanding. That may be the universe's most extraordinary feature, not its size, not its power, not its mystery, but the fact that within its vast, indifferent structure, it produced beings capable of asking what it all means. The universe does not answer. It expands, it fades, it endures its own laws. And somewhere, in a vanishing corner of space-time, awareness arose long enough to witness it, long enough to tell its story, before becoming part of the silence it once feared. The end.